I expect like many more to send the program. One tried, I think, what's the name? Only one guy keeps sending correctly, the more or less correct, but still the last program was little not perfect. But anyway, we can do it. Actually, we can see, we can go step by step how to understand and how we can do it by like, see, like we should not be taking the whole logic on a one stretch. Take the logic in a slice by slice, and slowly we need to digest. That's how we supposed to do. We'll wait for a few more seconds, just to see like somebody joins. So we have 4, 5, 6, 7, 8, 9, 10. Let us see, like 5 more minutes we'll wait. And if nobody joining, we go ahead. 5 minutes from now. Right, guys. So we have spent we have given enough time to join. So now almost like a 2:20. We can proceed now. I have seen like only one gentleman. He tried and then he sent the program also. Right. So I'm going to start from a scratch to make you understand how to achieve this kind of logic, right? So see, everyone can develop their own logic. See, like the moment when you say I said some logic, but my approach can be like different, like but still I need to achieve the goal, right? So let us try to achieve in the easiest way of understanding. Right. Let us quickly brief one more time the requirement logic. The logic is like the moment when I push and release the start I001, then my conveyor has to start, right? So basically, like when I push and release, see the logic I said to you, but even I do not know what is the logic, because like the program, because like I said to you, but I need to freshly think to implement, right? So when I push and release, that means like I can think of like setting the conveyor run, right? It's my first thing actually. And then in case if I am stopping it, yes, it has to stop. It's set, reset, flip flop can start stop this as well as this, right? Now then once I push and release, this can start very initially, so it can just roll, like the conveyor can roll very initially. Only the conveyor has to start, right? The conveyor motor Q07 may be slowly running. So while running, if the bottle comes on the conveyor, slowly will come and slowly comes nearby the sensor. Once it comes nearby the sensor will senses and it gives a signal to the counter. Then counter will start counting 1, 2, 3, 4, 5. Once the counter counts the number of bottle produced is 5, then we need to stop this conveyor. The reason why we need to stop the conveyor is like because if you run the conveyor, what will happen? More number of bottles will come into the packaging unit. We wanted to limit only 5 number of bottles to be put into the package. Once we put the 5 numbers of bottles, we want to stop it. If we don't stop it, it puts more actually, right? So we take the sensor. Once the sensor is more than 5, we stop it immediately. The time when we stop it, we can start the motor, the packing motor, so that the produced bottles, the 5 numbers of bottle what we produced, that can be moved, that can be shifted to the warehouse area, where that will be taken to the some other location, distribution lorry and many things. So then 5 minutes, so 10 minutes, 10 seconds after 10 seconds it would have reached there. After 10 seconds, because we need to do the second batch. See, it's a batching system. It has to do batch by batch. So after 10 seconds, again this motor has to start. The conveyor has to start. Once it starts, what will happen? Again the bottles will start moving. So once it starts moving, the packaging unit start getting the bottles into it. Again, when we toggle the buttons for 5 times, which is like a sensor giving a sensors like 5 times bottles, then stop the conveyor. You know it, like the reason why we stop is like we don't want further coming up. Then you start this packaging motor, then this item will slowly move to the like a warehouse area. Once it moves, then within 10 seconds it will move. Once 10 seconds is finished, again you can, what you can do, you can start the conveyor, so that like again further bottle can come, right? In between, in case if I stop it, we want to stop the whole sequence, right? Everything has to stop, right? So let us see, let us take start doing the logic. I'm going to do the logic now. So let us delete the all, right? So we had a two input, right? So the first one is the green. To start the process, we had a green, right? Then we had a red actually. This is to stop the whole sequence. Okay, input 1 and input 2 and input 3 is the proximity sensor, like which is like the bottle sensor. So bottle sensor, we can say sensor. So the first one, top one is a green color push button. Second one is the red color push button, and third one is the sensor, like bottle sensor. So now we need a output. Two output we need. So we'll take the first output. This one is a conveyor, right? Conveyor. And then we need another output. This is for the packaging equipment. Packaging. It's a packaging motor, right? That's it. So we require only these many. So only we need to build the logic in between. This is very challenging the job. See, so far whatever we did, it's very easy because like the anywhere if you go, people will say where they are connecting the wires. They will say, hey, I am connecting the start on the wire number, the point number 2. I am connecting the stop number, wire number 3. So based on the numbering address, you can give address like I001, I002, I003 in output Q001 and Q002, Q003, and so on, based on where they are connecting. So getting the address is easy, and taking the blocks based on how many IOs, how many inputs you required, how many outputs you required, it's also easy because like you know from the requirement. So now the important factor is like important part is how you build the logic. That is what you are thinking actually, because I'm sure, see, this logic development is really far simpler than what you work on the C language or like Fortran 77, whatever like you are working in the assembly language. I'm sure this is a really like very simple in construction, like very simple to do, and also it is a more value for you, like once you make it and when you execute, you are going to see in a realistic real-time life, and every time everybody is going to look at you like how you made or whatever. It's really like that time you will feel really highly appreciable actually, so you feel very comfortable. So it's a very highly valuable scope of job, but only thing is you have to be a little careful on building the correct logic. If you are able to think correctly, obviously you will be placed in a very well position actually, right? Now very initially what I thought is what I'm thinking is like when the green color is pushed, we want to start the process. When red is pushed, we want to stop the process, right? That is what we were told actually. Now in order to find this, like what I do, I will take a set reset flip flop. See, this is a lot of way to do implement, but I will choose my own way. Let us see, right? So I am taking the set reset flip flop, right? So when I start the process, when I click on the push button, the process can start. Anytime when I am pushing the stop, whole process has to stop. So I am using 1 and 0 here. That means now I decided now whenever I have 1 here, I will allow the process to process. When the value comes here 0, then I stop the whole process. It's a very simple actually, right? So this is my the initial thinking actually, because that's what the description is like. They say when I push the green color, the whole system has to run. Anytime when I push the red color, it has to stop, right? So now I use this one to decide further actually, right? Now now like the counting we can we can allow. See, this a lot of way, but I'm using a one way. When the counter counts, when the conveyor is not moving. For example, let us say the conveyor is stopped, but the sensor is giving a 101010, but that is actually not true, right? Because there is no conveyor movement. If there is no conveyor movement, how the bottle can move? Bottle cannot move. Maybe the sensor is malfunctioning. So the sensor 101010 can happen is a really that you can count it only when the conveyor is running. So what I'm trying to do is like I will consider the count only when the conveyor is running, right? So this is the initial running. Or you can take the conveyor running also, you can take this physical output also, you can take it out. We can take a physical also, like whenever the conveyor is running, see this queue is on. When the queue is on, that means conveyor is running, that time only really there is a sensor is going to come up, and that's what the real value. If it is a conveyor is not running, sensor is coming 1010, then somebody is playing with the sensor, or sensor has got faulty something actually. So we can count only when the conveyor is running. So I plan this way. I put a AND gate. Why do I put AND gate? Because I am thinking, what I'm thinking is like when the conveyor is running, right? When the conveyor is running, that time, okay, maybe I can bring it down just for right. When when the conveyor is running, that time, okay, when it's running, we'll decide actually, we'll decide a logic. When the conveyor is running, that time, if the sensor is giving a 10, that is a valuable, that is a really correct actually, right? It's not necessary you have to follow this step, because I did not tell this step, but I'm giving you the more understanding on it, right? When the conveyor is running, that time, if the sensor become 101010, then it is really sensor is sensing the product. Then when it is sensing, I wanted to count it, right? So I want to take a counter. I will bring a counter. Okay. So I will connect it to the counter, right? So while it is running, it is going to count, and the counter is going to go up. And then once the counter has come to the 5 count, what we want is like we wanted to start the this motor, right? See, we want to start so when the count comes 5, we wanted to start the packing motor. So what I do is like once 5 comes, the same logic what we built last time, I'll take the set reset, right? So then I'm going to connect it on the set, right? So I'll bring it here. So when the bottle counts are counted as a 5, then what we are doing is we are starting this this motor actually, right? So as we discussed, either you can use the on delay timer or off delay timer to cycle it, right? So what I can do is like I can do on delay timer. Anyone is okay, but just I'm taking a one way. So let me take a one way. It's an on delay timer. I have taken, right? So once the packing motor is started moving, I'm starting a timer. When the timer is finished, 10 seconds is finished, we want to stop it. Right? We want to stop it actually. This part is clear actually. Now, initially, when you start the system, we need to start the conveyor immediately, right? Then only the product can come, right? So whenever this is set, I can directly set it actually. maybe like a to see the simplest way. I'll reorganize slightly with a gap. Right. Maybe you can bring it here, slightly down. Right. So this is a sensor. We'll leave it. Okay? Right. So let us quickly run through this logic and see how much extent it work. When I push the green, the conveyor starts immediately. When the conveyor is running, while the conveyor is running, this sensor, if it is coming 1, 2, 3, 4, 5, so this counter is going to count up. So once the count comes 5, this will go and then it will go and set it. And once you set it, the packing motor will start, right? Packing motor starts, and then 10 seconds later it stops by itself. Remember, like we said very clearly, like when in the okay, let us come to here the PowerPoint. When 5 pounds, 5 bottles are collected here, we want to start this motor because it has to take the material to the warehouse. But we said clearly we want to stop this conveyor because conveyor should not start, because these motors we wanted to remove only 5 pack only, not single one. 5 pack one comes, we want to move it. So now the requirement is like we want to stop it. We want to stop the this Q1. We want to stop it. When do we want to stop the this Q1? This Q1 we wanted to stop it when this is running. That's what we discussed, right? See, like anytime when this is running, we want to stop it in a simple word actually, right? So now what I do is like the line what it is coming here, I will delete it. See, I am saying like when while running we don't want to start this, so I want to make a AND gate here, like a AND gate, right? This AND gate, like whenever the set comes, it can start, right? Whenever the set comes, it can start. But in case if this is running, then this should not run, because like remember, like I said, when this is running, it is taking the bottle to the warehouse. That time it should be in a stop mode. Once this is 10 seconds finished, this will go off, then it has to become on to collect the next batch. So what I want to do is like with a minor correction, like whenever this comes, you can start. However, this can go on only when this is not running, right? So not running means what? Like we need to put a NOT gate, right? Okay, I'm going to say I put a NOT gate here. See, I put a NOT gate and I connect. Sorry, I connect. Ooh, I'll connect. Connect this one and then this one. Right. So we made a, maybe let me delete and do again NOT gate, and I will wire it. And then the NOT gate output, I'll give it to here. So what I'm trying to achieve here is when this packing motor is running 1, then it gives a 0, it comes a 0 and it stops the motor. Whenever the packing motor is on, we want to stop the motor. That is what the intention is. When the packing motor goes off, if my system is running, then it can allow it to run, right? So this is a very preliminary logic what I made, but still I'm not sure whether I have implemented everything. So let us evaluate one time. Like let us try to check by running through the logic. See, logic is like logic won't come immediately in a one step. You have to do step by step and evaluate and make sure it is working correctly. Right. Let us go from a scratch. When I am pushing the green color button, we want to start this motor. Right. When I'm pushing it, I have kind of on a set. This will set and it will give a on. So on will come and it will go through the AND gate and it will go and start. Now, very initially, this one leg is on. The next leg is what? We check the next leg where it's coming from. It's coming from the Q. The Q is like this is a packing motor. Packing motor initially off only. When it's off, then the output of the NOT gate will be on. So it will be on. So this is also on and this also on. Since both are on, I get the Q coming up. So my conveyor will run. Okay. So first my logic is tested. When I'm making it on, my conveyor will run. Okay. When my conveyor is running, my sensor is sensing. Then when the conveyor should be running in order to sense the sensor, because we want to take a real sensor bottle movement, not the false. Okay. This I did not tell, but if you do not have it, it's not a problem. But I'm telling you like just to make a foolproof programming. The program is supposed to make a full-fledged way, fully functional, like without loophole, and it should work in even if the operator says they may not be telling some problems, but we need to think of all the problem and we have to implement, right? So when the conveyor is running and if the sensor is coming, then we are start counting it actually. So 1, 2, 3, 4, 5. Once the 5 comes, then we are setting it. Once we are setting it, the packing motor will start. So remember, like when we said, when the packing motor is starting, we have to stop immediately the conveyor motor because we don't want the single bottle falling on it. So once it is on, if you look at here, on means it will become this NOT gate will become off. When it becomes off, then on is there, one leg, other one is off, so you get the off. So this will go off. So now this will be on and this may be on for next 10 seconds. After 10 seconds, this comes back here and then it will reset. Once it reset, what will happen? The Q will go for off. Once becomes off, then what will happen? If you here it will become off, but whereas the output become on. So already on is there, on is there, then it goes on, and then the cycle starts continue, and this is how it keep going. But anytime when you are stopping it, right? When you stop it, it'll go off and it will reset this, and this also will become on, the off. It means like the cycle will terminate there actually. Hope it should be clear. Let us try to see. This is my initial programming. This is my thinking on my brain actually. So sometimes like when you think, it may not be the correct when you execute. If there is not correct, we can always correct it. See, that's how the logic won't come at a one stretch. There can be some loopholes. Something may not be working. Even when I explain, when you look at somebody, maybe somebody would have pointed out, hey, something's not correct. This may not be working. Something you may think it can happen. Okay, it can happen too. But we need to try it out actually. Now, one thing what I missed is like this reset I missed. So we can use we can reset it also. Like we can check the reset here, right? Because after five bottle we have to reset, right? That we have missed it actually. So I am resetting with the same reset actually. Right. In my opinion, it's supposed to be working, but still we have to evaluate and find out if there is there any loophole in this, right? So what do I see here actually? So okay, either on and off, both are there, right? Let me switch it off. See, the program what I implemented is correct as per my mind actually. So, but still, when I execute it, there is a small glitch happening. Like there is small cycling on top. Even I did not start. It is showing me the top one is going on and off, on and off. Just I'm trying to find
Or
out
we have to give specifications, sir.
which one, boy.
Counter and on time delay
Uh,
specifications, sir.
Acha, oh, I did not set the time. You mean say right? Okay, correct. See, somebody's like watching carefully. Right, right. So I set the time there. Let us see how exactly. After 10 seconds, so it's keep running. Why it is getting reset again? Is it resetting it?
Our counter is 0, sir.
Say again.
Counter.
Yeah, counter is 0, so that means it should not start actually because maybe like I have given wrong connection actually. No, that's correct actually. So this is reset, this is going, and this is setting it. This is reset. So as per my understanding, this looks to be correct, but still there is a small loophole which is blocking from the cycling. Something is cycling out. Let us see. When becomes on, it is resetting. But why it is? Right, boy. You said correctly. Right. See, you whatever you said is correct because the count is 0. Perfect, boy. It's a very good observation. Right. Right. It's a very perfect observation because 2 observation was very good. The timer, because when I do initial program, I was thinking like the only the logic part, but the entry also very important. So 10 second I missed here. That is a problem. And then here 5 count because it's giving a 0 count also is giving. But the only thing is what is happening because it is happening executing very fast. We are unable to figure out what could be the possible reason. So you have to be a little smart. You have to be smarter than PLC. Then only you can catch up the problem. Otherwise, it's very hard to catch up the issue. Anyway, I'm happy somebody is watching me very careful, right? Now we are going to simulate the logic. This is your initial logic. What we put on our brain, it is executing correctly, but we want to check is this logic correct or not, right? Let us check it now. I want to start the system, so I'm starting my conveyor. I pushed and off like it's a button. I pushed it and released it. When I push and release, so I could see my conveyor is running. So this is a very basic one because this is the conveyor only moving my bottle. Like if you see the picture, the conveyor is very important because conveyor start has to move. If it is moving, then only the bottle comes. Otherwise, no bottle comes. So now, while moving, if my sensor comes, like I say, sensor becomes 1. So my counter has gone to 1. Then my counter has gone to 2. My counter has gone to 3. My counter has gone to 4. So next time when I am giving a fifth bottle, so what should happen? Like what I expect is the packing motor has to start, but at the same time the conveyor motor has to go off because we don't want that to be operated. Otherwise, like the bottle will come and fall somewhere because the packing is already moved actually, right? So let us try to do is it happening that way. So I'm making this on. So now what is happening? Only the packing is on, the packing motor is moving, so it is mobilizing the package to the warehouse, and that's what it happened. Like now, after 10 seconds, the package motor has gone off, and conveyor is running now because conveyor is like a ready for next batch. So now if I start again 5 counter number 2, third bottle, fourth bottle, and make if I say fifth bottle, now fifth bottle again the conveyor is stopped because we don't want any movement, but the packing motor started. It is mobilizing the packing to the warehouse. So now what is happening? This cycle keep continue. Like you may be thinking like, say, like when the conveyor is running, why do I like simulating the sensor? Because I need to do a simulate, right? Okay? In a real time scenario in a company, When it is running, the conveyor is moving, bottle will definitely move because bottle is there actually. And this sensor will go on off based on the sensor what is sensing here actually. But since I do not have that online system, I am simulating on behalf of this switch. I am simulating on and off, on and off, and then that is how the I'm testing sequence. So like but the whole sequence is continuous. Like the if I make a 5 bottles, then the cycle will proceed. So I'm making my 5th bottle. So now packing is moving, the conveyor stopped, so no bottle coming up. So it should be this way. And then once the packing is moved, now my conveyor is moving. So when my conveyor is moving, again my sensor will come. So I will go for a 5. Then again my packing moves, conveyor stop. So this is a kind of a cycle it is keeping doing. But now I wanted to stop the whole system. I don't want to start it. Then what I do, I'll push this red color, right? Once I push the red color, everything is stopped. So now even my sensor is, for example, my faulty sensor. This is my faulty sensor coming 10, 10, 10, 10. Whatever comes 1010, it won't be counted because the conveyor is not running. While conveyor is not running, the sensor cannot give. But even the sensor is giving, we don't want to trigger any of the action because that will paralyze the system. Because when everything is stopped, when somebody is cleaning the sensor, then it will start the packing motor by itself. No, we don't want that abnormal condition. So we have to make sure the logic what we make supposed to be like a perfect, and it makes sure no loophole, it works correctly. That's what it is done. I hope it should be clear, and if it is not clear, you can ask me, I can repeat it, that's not a problem. So I can stop from now for 1 minute, and then if you have any question you can ask me. Time start now. Right. So guys, I presume that the logic explanation looks to be okay to everyone, and everyone understand correctly. That is what I presume. Okay. So hereby, like we close this class. Like basically, like the intention of this the class is like to make sure you understand the counter logic. Not only counter. See, with this example, we have covered almost everything. So we have covered AND gate, we have covered the on delay timer, we have covered the set reset flip flop, and then we covered the counter. All have been brought into this logic. So if you really understand this logic correctly, that means this confirms that you are more or less clear on so far whatever we have gone through, everything is clear. That's what we presume actually. And right, guys. So, like now we will terminate the class, and the rest of the day you can enjoy. And let us see by tomorrow 9 o'clock, same time 9 o'clock. We will continue with the remaining blocks, like remaining like comparator and the other function blocks. We can continue. So with right now, as of now, whatever you have learned, if you have really learned correctly as of now, then this covers normally like almost like 70 to 80% the logic will cover with this. The remaining is like a very less. The remaining are not used much, and the remaining is not so critical also. This is the much more critical. This as long as you know as of now whatever we discussed very well, I'm sure you will be able to manage reading the logic what is implemented, and in a site if they ask for any modification or any changes, you will be able to do online immediately, right? That's what we presume, provided if you understand everything correctly, right? So hope you understand correctly. If any question you can always ask me. So we will break the class now, and we will see you by tomorrow 9 o'clock, right? Okay, thanks boys.